Right now, Azul's faking thread priorities with duty cycle style locks and blocks, where we count how often things are running and we block or unblock people. It's really stupid. This really belongs in the OS. The OS is already doing process priorities and context switching. Damn it, do thread priorities within a process as well. And people come along and say, well, you just lower everyone's process priorities or everyone's process priorities, because they are the thread priorities as well. But that has bad interactions with other processes running on the same box that don't match your expectations of this JVM is typically load sharing with that other, it's my Apache, PHP, Java, all in the same box. If I lower my Java thread priorities, then they just lose. And they need to be like load sharing. It's not the right answer. Okay. Things I think belong above the JVM, and that would be alternative concurrency, right? The JVM is providing this nice sort of building blocks, fast locks, thread management kind of infrastructure. But there's a lot of these new languages that have new concurrency ideas, and I would love to find out which is the right one, and I have no idea what the right one is, so we should experiment, right? So message passing, software transactional memory, actors, fork join, whatever, there's lots of them. And the JVM is just too big and too slow to move fast here in sort of a researchy way and provide, oh, today we're going to provide fast actors, or tomorrow we're going to provide fork join, but no, it's not happening. So, so experiments should be run above the JVM until we get some consistency, some consensus on what the right way to do concurrency is. And when that happens, maybe the JVM comes back and says, okay, we'll provide you the building blocks. Like, we suddenly discover that STM is the way to go. Maybe the JVM either does the STM or provides services to let you write an efficient STM or whatever. But until then, I think people should experiment on alternative concurrency models above a JVM. Use the JVM's, JMM and fast locks as a building block. And then let's try some different concurrency models and see what people end up liking. Fixed nums. These are things that are being implemented by hand by different people who like to have sort of the infinite sized integer model at the language level implementation, so Clojure and JRuby and some of the guys. And JVMs only provides a primitive int and long, and so people want the sort of ideal int with obvious translation to infinite math, but that's really inefficient to do it at the bytecode kind of level. And it's hard for the JIT to recognize that's what you're trying to accomplish. So you really want some kind of tagged integer support in the JVM itself, and that means the JIT has to be sort of intimately involved in tagged integer support. And there I am. I think 64 bits ought to be enough for anybody. Click quote. And you, as the application level program, know if you might actually need more, because almost surely you don't. So don't make everyone else pay for it. I think the right model for these alternative languages, you can ask for fixed nums if you want, but don't make everyone pay for it by default.
Another painful memory. Gosling comes over to look at Self while they're developing Oak, which later became Java. And we tell him how nice it is that we use tag integers like small time. No, that's terrible. Too slow, never work. Doesn't ever put them in Java. And so, gosh, do I feel vindicated today.
Well, as even more vindication for this point, big pain point in Java is we need fixed nums just to do generic collections, right? You want to have a collection of integers or a map indexed by integers. If you have to box everything, it's a disaster, right? So just to do the ordinary kind of code abstraction that we're telling programmers to do, we have to give them faster boxed integers, like fixed nums. Just for ordinary Java code, not even for other languages.
So up a language
separate out fixed nums, which overflow silently into big integer math, from boxed integers, which let you make function calls on an integer.
Right. So what Java programmers need are fixed nums that overflow into boxed integers. They don't need to overflow into big integers.
Yeah, that's what I'm saying. So boxed integers are different.
Yeah.
So I'm saying here that very few people need integers that overflow 64 bits. Silently, correctly overflow 64 bits. But a lot of people like to have integers which wrap automatically. So that's autoboxing. This is tagged integers as opposed to autoboxing. So separate out the two different things. And then the short-term solution is you make 5 different copies of your collections APIs where the keys are little case ints.
We really tried to get Gosling to go the small talk way.
So I'm not ranting against that one, although I have. I think it's all right, fine. I'm just providing the 5 versions and saying that okay. Okay, things to keep in the JVM. Like JITting by itself, I think is a fine thing to have at this point. It's sort of not doing anything OS-like. It's a standard sort of classic single-threaded serial process of read in some bytecodes and produce out some machine code. It does something that's sort of very straightforward. So I think it belongs in the application, in the JVM level itself. It's a nice service provided application. As soon as you put the JIT there, you have a bunch of other constraints. GC, whether or not you might want it somewhere else, it requires deep hooks into the JITting process. And so in that sense, I think GC belongs with the JIT and therefore at the JVM level. But in fact, I think it makes a lot of sense to have it below the applications level itself. People want to get away from the notion of having to track their memory, because that's the hard problem that malloc and free gave us from the C days. And you had all these resource areas and arenas and zones and God only knows what people did that were all bogus attempts to do things that were GC-like, where GC just does the right thing. Okay. The Java memory model also requires deep hooks into the JITting process. And again, I think mostly makes sense for the app, although there are some concurrency models where some magic thing about the concurrency to say, I can have a much weaker memory model because I'm doing, for instance, Erlang style actors, whatever, and it's all immutable messages being passed around. And since it's immutable, I don't need any sort of coherency control, and I can use faster, cheaper hardware than the standard, very conservative x86 stuff. But this is still, in the end, going to require close JIT cooperation. So I don't know, if you start going down this route, if you want to add a new version of the jitter which says, the memory is free to reorder when you like because it's all write once, read only kind of stuff. I don't know how you talk to the JIT about what the rules are there that will let you do better coding and then run faster on faster hardware. OS resource lifetime management. I think this doesn't belong in finalizers. This has to do with applications. Make the app guys do reference counting or arenas or resource areas or whatever they do, some sort of lifetime management. And don't make the GC have to deal with knowledge of more of resource X can be had by running finalizers. That's sort of a bad plan in general, in part because there's not very many of these hooks right now, and there's no good place to hook the GC, but also I don't know what resources you eventually want to come in here. And then there's these there's timeliness guarantees. If I have to run a full GC cycle in order to get finalizers run to go your file handles back, does Tomcat stall until that full GC cycle runs and he gets his file handles back? Or do I need to have a predictive heuristic saying, well, we're using 100 file handles a second, and we've got 65,000, we're going to be out in 30 seconds, but I can run a concurrent GC cycle. If I start it soon enough and the finalizers around, I'll catch up. And what kind of predictive heuristics do we need to do there? The GC doesn't need to try to play that game with every kind of new, different OS resource that comes along. This job needs to be done somewhere else, not in the GC, right?
Can you provide similar GC semantics, though? Instead of having memory as the only GC resource, you could have file handle, resource management, blah, where you never say free, and that's all taken care of by itself.
I started putting slides in exactly to talk about that, and I thought I had way too many slides, so I backed off. But I think that might be useful property, and then I don't know whether that makes sense to have it in the JVM or as an application service like you get from the rt.jar as a library. You can declare a new OS resource and tracking lifetimes and watching it flow out and then proclaim it's time to go do something. I don't know.
I think there was a paper by two of Alex Aiken's students at PLDI a year or two ago doing pretty much just this.
Some sort of generic way of describing external resources as lifetime are tracked by objects.
For OS resources.
For OS resources. Yeah. But also by objects are tracking the life, like the OS resource is kept alive because I got an object pointing to it. And now when do I run GC cycles in order to declare the object dead and that kind of stuff.
So why don't we write an obnoxious letter to SOSP and tell them that it's time they gave us something better than file handles, which are based on small integers, which were efficient on a PDP-11, right? I mean, if the OS API were better, this wouldn't be a problem.
I'll let you tilt at that window. Okay.
It's so obvious.
Absolutely, go for it. Let me know when you get it done. Okay, weak soft phantom refs. Okay, fine. They changed the program semantics. I got a concurrent GC running, cycling. It's decided it needs to cycle really fast because you gave it too small a heap and your heap's growing too big. So the concurrent GC is running really, really fast. So I make a soft ref, GC runs at 0. I make a soft ref, GC runs at 0. Next clock cycle, every clock cycle. You make a soft ref, the semantics allow it to be 0 on the next clock cycle. And we have apps for which that's happened to us at Azul when people did the wrong sort of things, and their programs all broke. Okay, fine. Your program semantics change because a GC cycle ran. It's like, really, guys? Do you want to go there?